The final inverse function, trigonometric inverse function that we're going to look at is the arctangent or the inverse tangent function. Much like the inverse sine and cosine functions, two ways of denoting the inverse tangent. We can either use the tan minus 1 notation, or we can use the arctan notation. Again, and I've stressed this in the first two videos, and I'm going to stress it again, that tan minus 1 is not the same as 1 over the tangent of x. Okay, so that is not that function. That would be the cotangent function. Okay, so that makes no sense for us to try to be able to state it in three different ways. All right. Now, if we look at the graph of the tangent function, what's different about the inverse tangent function is that the regular tangent function has asymptotes. All right. And one cycle of the inverse tangent function has an infinite range. Okay. And remember, what we're doing is we're swapping the domain and the range for an inverse function. Okay. And so what we're doing is we're saying, okay, well, if the point pi fourths comma 1 exists, then the inverse function would have the point 1 comma pi fourths, which it does right here. Right? And also similarly, if we have negative pi fourths negative 1, then we would have negative 1 pi fourths. Okay, so notice that those interchange with one another. Okay, now another thing to notice is that the vertical asymptotes of the tangent function become horizontal asymptotes on the inverse tangent function. And so our inverse tangent function looks like this. Okay, it's different than the sine, inverse sine and cosine function because the domain is all real numbers. So you can plug in any number you want into the inverse tangent function and you will get an output. Okay. Now, the range, though, the output is only between negative pi halves and pi halves. And so on the unit circle, similar to the arc sine function, that's only these two quadrants, 1 and 4. All right. So for tangent and also sine, or arc sine and arctangent, those live in quadrant 4, right? The arc cosine lives in quadrants 1 and 2, all right? Now, we have to remember that to get the tangent function, it might be helpful for us to remember what the values of the original tangent function are, okay? So if I had these angles, and these are common angles, okay? So we have 0, and we have pi 6, we have pi fourths, and then we have pi thirds, and then we know at pi halves it's undefined, right? It's a vertical asymptote. If I wanted to find the tangent at that angle, okay, remember tangent is y over x, okay? And so at 0, it would be y over x, 0 over 1, which is 0, okay? And then I'm just going to put these in here so that way we have them, okay? So 0 here. And then at pi 6, okay, well, that would be 1/2 over root 3 over 2, or 1/2 times 2 over root 3, or that's the same as 1 over root 3, or if we rationalized it, that would become root 3 over 3. All right, so, and the reason I'm writing these out is because it's tougher for us to get the tangent than it is to be able to get the arc sine or the arc cosine functions, or the sine or cosine functions, because those are just x's and y's. This is a ratio of y over x. The easiest one is pi fourths, because that's going to be root 2 over 2 divided by root 2 over 2, which is equal to 1. And then at pi thirds, we would just have y over x. So that would be root 3 over 2 divided by 1/2, or root 3 over 2 times 2 over 1, which is root 3. All right, now, I would recommend that you probably want to have this table memorized by now, okay? But if you can't memorize it, then what I would do is make sure that you can derive it, okay, by doing the y over x, okay? Because these are going to help us to be able to get the inverse tangent values, okay? So now that we have this table, we can actually start trying to evaluate some of these arctan sorts of values, right? So we have the arctan of -1. So if we go into that list that we just made, well, at pi fourths, we have 1. And so what we're going to do is we're going to go the other way to be able to get -1. Okay, and remember the trick that I showed you in the sine video is just worry don't worry about the 7, just change that to a negative, okay? And so that's going to change, that's going to mean that there's some angle that gives us the arctan of -1, which means that the tangent of some angle is -1, and that angle theta is going to be equal to -pi4. Okay, so again, if you go into the unit circle, we just did this. If you just make these both negative, okay, that's how it works. Okay, and you could clearly see that if you were to divide these two out, you would get a -1. Okay, but it's just easier for us to just have this table. Okay, so again, the sooner you have this table memorized, the better it'll be easier, or the easier it'll be for you. Arctan of 0, well, that's the easiest one. We just go in here and we see that 0 is 0. Okay, so at angle 0, you have measure 0. Okay, so this would be equal to 0. And again, that's because theta is equal to arctan of 0, which means that the tan of some angle is equal to 0. Okay, I keep writing this out so that way you all can see what it is particularly, what we are looking at particularly. Okay, and so the tangent of 0 we know is 0. Okay, so that's what we're looking for. If we're looking for -√3/3, right here, we have √3/3 at pi6. So it would go to suggest that from here, again, the trick is just worry about this and just change that 11 to a negative, and then that'll give you what we're looking for, which is -pi6. Okay. Finally, for the square root of 3, we go to a unit circle, and we see at pi3, we have √3, all right? And so that's going to be equal to pi3. Okay? Again, we should use a calculator just to make sure this is correct. So we want to bring up the inverse tangent of the square root of 3, okay, which is equal to 1.047. Now remember, we said that that was pi/3, and that's exactly what it is. Okay, so make sure you're in the radian mode. Okay, you don't want to be in degree mode. Okay, when you're doing this on your calculator, and then that should help you to be able to evaluate these arc tangent sorts of functions. Okay, so in summary, okay, this is probably, so besides the graphs of the functions, what they look like, okay, the most important stuff to remember is which quadrants on the unit circle these arc functions live, okay? And so arc sine and then arc tangent, okay? Those both live in quadrants 1 and 4 on the unit circle, okay? The arc cos is going to be in quadrants 1 and 2. All right, so this is helpful to memorize because that's going to help you when you go through to evaluate these inverse functions. Okay, they're not hard to evaluate, but you have to make sure you have this memorized. Okay, otherwise it's not going to work out too well for you. All right, so in our next videos, what we're going to do is we're going to take a look at some expanded definitions of some of these inverse trigonometric functions.